A pleasant greetings to all. In this video, I am going to solve some of the problems in NPTEL. The subject is Fundamentals in Electrical Engineering. Week 1 and Assignment 1. The question number 1, determine the amount of power supplied or absorbed by the load in the given circuit. In any circuit, power absorbed should be equal to power delivered or supplied. Power absorbed equal to power delivered. Power delivered or power supplied. Okay, see here. First see the component number 1. This is the first component. See the current positive delivered. So you have to remember like this. Positive delivered means power delivered. Positive absorbed, that is power absorbed. Here positive absorbed, power absorbed here, power delivered. And here power absorbed again. So first of all, I am going to add the power absorbed, that is equal to power delivered. Normally, power delivered is indicated by negative sign. Power delivered means negative sign, and power absorbed is positive sign. Power absorbed, that is positive sign. Okay. Next, power absorbed. So this is the component number 1. Component number 1, the power is delivered or absorbed. The power is power delivered, positive delivered or power delivered. So what the current is 5 and voltage is 120. So 5 into 120, that is 600. Okay. Then is there any power delivered? Here also positive delivered. So 3 into 60, that is 180. Okay. Next, power absorbed. So what I hear, the positive absorbed or power absorbed, 5 into 80, that is 400. The load, the power absorbed in the load. And see here, 100 volt also, positive absorbed or power absorbed, 3 into 100, that is 300. Okay. Now see here, 400 plus 300, 700 plus load. In the load, power is absorbed, that is equal to 780. So what is the power absorbed in the load? Power absorbed equal to 780 minus 700, that is 80 watt. That is the power absorbed by the load, 80 watts absorbed. This is the answer for the question 1. I am going to explain second question. For t is equal to 0, q is equal to given. Then calculate the amount of current that will flow through a circuit at a time 2 milliseconds. Okay, what is the equation or what is the relation between current and charge? I is equal to dq divided by dt. Okay, see here, I equal to dq is given. So 0.02 differentiation of 0.02 into 1 minus e power 2000 t. Okay, then I have to differentiate this. So 0.02, here 0, here minus of minus 2000 into e power minus 2000 t. Okay, so 0.02 into 0.02 into 2000 into e power minus 2000. What's the time given? 2 milliseconds. Okay, 2 into 10 power minus 3. Okay, now 0.2, so these 2 points are cut. So 2 into 20, that is 40. Okay, 0.02 into 2000, no, 40 into e power minus 4. So what is the answer now? What is e power minus 4? I have to use the calculator and find out the answer. E power minus 4, that is equal to 0. The answer is e power minus 4 is 0.0183. Okay, that is multiplied with 40. That gives the answer 0.732. That is the current in ampere. So that is in between this one. So B is the correct answer. Okay, next I am going to the problem number 3. the power supplied and voltage across 2 ampere current source. 2 ampere current source. So first of all, I have to mark V2A. This is the voltage across 2 ampere current source. Now I am going to write the equation. So this is the voltage rise. So 2V2A. See here, what is the, here voltage drop or rise? Here voltage drop. So 2 into 2, that is minus 4. Here also again voltage drop, there is minus I1. I1 equal to what? 2. So that is equal to 0. So V 2 ampere equal to 6 volt. Okay, then 6 volt. Then what question? Power supplied by the current source. What is the power supplied? Power supplied is I into R, I square R B into I. That is the formula. So what is V? V is 6 and what is I? I is equal to 2. So 12 watt. The answer is 12 watt and 6 volt is the correct answer. Next, the voltage and current across the element is given by 100 e power minus 250 t and 50 e power minus 250 t. Calculate the energy delivered by it in joule. Okay, for t is greater than or equal to 0. What is the energy? Energy is equal to dW here, power equal to dW by dt. Okay, that is the power. So what is energy? Energy is dW, that is P into dt. Take difference integration on both sides of the equation. So W into, what is P? The multiplication of current into voltage. So e power minus 250 into 50 into e power minus 250 into dt. Okay, T into dt. So 50 into 100, that is 5000. Okay, correct. 5000 into e power minus 250 t into dt integration. Then 0 to infinity is greater than or equal to 0. No. So 0 to infinity is the limit. So 5000 into, what is the different integration here? Minus 250 divided by minus 250. Okay, see 0 to infinity. So here 0, so 500 divided by minus 25. Okay, into e power minus 250. So first of all, you have to substitute the upper limit. So if you substitute the upper limit, e power infinity. So e power infinity minus 0. Okay, e power infinity means what? 0. So 1 by e power infinity. So 1 by e power infinity, 1 by infinity, that is equal to 0. Now here already 1 minus e power 0 is what? 1. E power 0 is 1. So 500 divided by 25. So what is the answer? Here 20. 20 is the answer. Problem. The resistance of a wire of length L and diameter D is R. If the length is reduced by 50% and the diameter is increased by 100%, then the new resistance will be. So first of all, I am going to write the old resistance. Old resistance is rho into L by A. This is the old resistance. Here rho into L pi by 4 into D square. Okay, because D is given. Next, new resistance I have taken R nu. R nu is what? Rho into L nu by A nu. So A nu, that is equal to rho into L nu divided by pi by 4 into D nu square. Okay. Then what is L nu? What is L nu given? The wire of length L and diameter D is R. If the length is reduced by 5, so already the length is L. If it is reduced by 50%, so L by 2, isn't it? L by 2. So 2L minus L by 2, that is L by 2, that is L nu. What is D? What is D nu? D nu means diameter is increased by 100%. So 100 by 100 into D. So D again D. So 2D. Okay, now what I have to do, I have to substitute the value in this equation. So L nu is L by 2 divided by pi by 4 into, what is D nu? That is 2D square. Okay, then rho into L by pi d square. You have to separate this into here what you get, that is 8. Already 2 into 2, that is 4. 4 into 2, that is 8. So what is the answer now? Here the value is r, equal to r. Okay, this is the value equal to r. So r divided by 8 is the correct answer. Okay, A is the correct answer. Next, if n nodes, B branches and L independent loops, okay, this given, are there in a network, the relation between them is equal to. So first alphabetic order, okay, you have to remember like this. So what you have to B, then you have to L plus n, you have to write like this minus 1. You have to write in alphabetic order, means B will comes first, L next, n next to L. So B is equal to L plus n minus 1. In this way, you have to remember. Next problem, the current through an element is shown in figure. The total charge passed through the element from 0 to 9 seconds. 0 to 9 seconds they've asked. But 10 seconds, up to 10 seconds they'll give, but they asked up to 9 seconds only. So first total charge, Q is equal to IT. Okay, that is the formula. Q is equal to IT is the formula. Okay, now first time is given, current in ampere is given. First you have to take this triangle first. In a triangle you have to find out the area. So area of the triangle, so half into BH. Area of the triangle is half BH. What is base? Base is 2 here. What is the height here? 0 to 12. That is height is 12. The first one is over. And the second you have to consider the square. The square a rectangle. Okay, here 2. So 2 into in the y-axis 12. Okay, 2 into 12. Okay, next, see the next one, we have to divide into triangle and square. In at the same triangle, 2 into 12. But rectangle. And here this is the triangle. In the triangle, what is the base? Half into 6 minus 2. 6 minus 4. 6 minus 2, 4 means what? 2. B H. What is H here? 12 and entered in 30. So 8 to 30 minus 12. So 30 minus 12, that is 18, isn't it? 18. And next, what the value next is 6, 9 minus 3, 6. Next rectangle. Okay, 3. So 3 into, here the height is what? Height is 30. Okay, 3 into 30. Okay, now you have to cut this. So first you have to write 12, 24 plus 24 plus 18 plus 90. Okay, you have to add all this 24, 24, 48, 18, 18, 12, that is 30, that is 78. So what is the answer? 168 coulomb. The answer is 168 coulomb. The answer is in between 151 and 200. B is the correct answer. Next, across any two terminal, in case of open circuit and short circuit, the value of resistance will be. See here, in an open circuited terminal, is there any voltage? Voltage equal to 0, correct? Voltage equal to voltage equal to infinity and current equal to 0. So voltage equal to infinity and the resistance also equal to infinity. But you have to consider the short circuit path. Short circuit, the current is flowing, but the resistance is 0 here. There is no resistance. Voltage also 0 in the short circuit path. That's all. Next, I am going to explain the problem 9. In the given circuit, calculate current drawn and conductance of the lamp if battery provides 200 volt and power rating of a lamp be 200 watt. Okay, voltage is given, that is 200 volt, and wattage also given, power 200 watt. But what they have asked, that is current drawn and conductance of the lamp. What is the current? Current equal to, here power is given, so power P is equal to V into I. So I is, they have asked about the current. Current equal to P divided by V. So what is the value P? P is 200 and voltage also 200. So what is the answer? 1 ampere. Okay, next we are going to find out the conductance. So what is conductance? G is equal to I by V. Okay, I by V. What is I here? I is equal to 1 ampere. What is V? V is 200 volt. Now what I have to do? 1 by 2 is what? 0.5 into 10 power minus 2. This 2, 10 power minus 2. Okay. Here multiply both numerator and denominator by 10. Now this come to the numerator means it will convert it into 10 power minus 1. 0.5 into 10, that is 5. So 10 5 into, that is 5 into 10 power minus 3. So 5 millimole, not ohm, millimole. So that is the correct answer. Okay, next problem. In a cyber cafe, total load consists of 6 lamps of 20 watt, 4 fans of 75 watt, 10 computers of 200 watt, 2 air conditioner of 1500 watt, and 2 printers of 50 watt. If the supply to 30 volt and basic monthly meter charge is 100, then for average loading 50% throughout the day, what will be the electric bill for 1 month? Assume cost per first 500 unit be 2 and after 4. Okay, that is given. So first of all, you have to calculate the power consumed by all loads. Okay, so load number 1. 6 lamps of 20 watts. So 6 lamps of 20 watt, that is 120. Okay, first one is 120. And 4 fans of 75 watts. So 4 5s are 20, that is 300. And 10 computers of 200 watt, that is 2000. Okay, and 2 air conditioners of 1500 watt. So that is equal to 3000. Okay, then 2 printers of 50 watt. Okay, that is 100. That's all. So now I am going to add all this 0, 2, then 4 and 5. 3 plus 2, that is equal to 5. Okay, 5520. But if the then for a average loading of 50% throughout the day. So average loading 50%. So 5520 into the average loading 50 by 100, 50% average loading. Okay, now 5, that is 2, 2 2s are 4, 2 7s are 14, 60. So 2760. 50% throughout a day. What will be the electrical bill for 1 month? 1 month electric bill they have asked. So 2760 in day 24 hours, and the total days in a month is 30. So 2760, I have multiplied using calculator. 2760 into 24 into 30. So into 30, that is equal to 198720. 1987,200. Okay, this is in watt. Now convert this into kilowatt. So divide it by 1000. So it will be cancelled now. So 1987.2 kilowatt. Okay, 1 kilowatt means 1 unit. So 1987.2 kilowatt. Okay, here 1 kilowatt, that is equal to 1 unit. Okay, what they given here, assume cost per unit for first 500 unit be 2. So first 500. So first 500 unit, that is 2. So 2 into 500, that is 1000 rupees. And remaining means 1987.2 minus 500. So that is equal to 7, 8, then 4. That is 1487.2. So minus 1487.2 into the value is 4. Okay, so 5948, 5, that is our remaining value 1448. 487.2 is, what's the rate? That is 5948.8, and afterwards you have to add 100 also. That's the minimum meter charge, basic monthly charge. So 0.8, 8, 4, 0 and 7. Okay, 7048.8. Okay, so that is in between 7,000, 7,499. So that is the answer. Okay, next. Following circuits are invalid. So you have to mark the invalid circuit. See here, B1 is 10 volt, that is supply. Here also 10 volt, here also 10 volt. Here should be 7 volt. This is the parallel circuits. So all the voltages will be same. But see here, Vs is 2V1. So this circuit is wrong. Okay, then see here, V1 is 10 volt, but here I is V1 by 2. That is the correct circuit. And see, I1 is 2 ampere. The 2 ampere is flowing through an entire circuit. So Vs equal to this is also correct. And see, I1 is 2 ampere, but here that given is I1 by 2. No, that is wrong because only one current is flowing. I1 is 2 ampere. So this is also wrong. So A and figure D is wrong. So B is the wrong answer. So B is wrong, but that is the correct answer. In a house, net energy consumption in a day is 27.6 kilowatt hour. Supply is given. Supply voltage 230 volt. And what is the current in amperes? So what is the formula for current? Current is P divided by V. So first of all, you have to find out the power. So how to find out the power? Energy by time. Energy by time. Okay, here kilowatt hour is given. So 27.6 into 10 power 3 divided by the time is what? 24 hours. So you have to divide this, and that is 27.3. So 276,276.00 divided by 24. So first of all, I have to divide this divided by 24. That gives the value 1150. Now P is known. So from P, I can easily find out the current. I is equal to P by V. P is equal to what? 1150 divided by 230. So divided by 230. That is equal to what? 5. The answer is 5 ampere. Okay. Thank you. Have a nice day.